Hello, my name is Jonathan Broadwell. Today we're going to be looking at the Serial Wombat 18AB chip's ability to read analog inputs and scale and manipulate those for use by other pins on the Serial Wombat 18AB chip for feedback control. Specifically today we're going to use a current sensor hooked up to a servo to see when that servo is driving to its edge, essentially when we see a current peak as a result of a servo stalling. We can take a look. If you look at the video linked up above, we saw that we have a current sensor that is attached to pin number 19 on the Serial Wombat 18AB chip, and it's a 5-volt current sensor. That's a 5-volt sensor. It shoots for 2.5 volts nominal when there's no current, and it senses positive or negative, so you can get a positive or negative result. The way I have it hooked up, a positive current actually drives a negative voltage result, which is a convenient way to deal with the fact that it's a 0 to 5 volt sensor, and we only have a 0 to 3.3 volt input on the Serial Wombat chip. So as current goes up, the voltage signal that we get will actually go down, which is fine because we can adjust all that in the Serial Wombat chip. I'll close what I've done so far and show you how we do that. I've opened up on the Serial Wombat panel the ability to access the Serial Wombat chip. I'm going to say configure on my analog input and hit go. And right now we can see on the video that the servo gripper is neither open nor closed. So it's not really pulling too much current. It's not having to work too hard. That's on pin number 18. And so now as I take and push this, let's get this so we can see what's going on. As I push this to one edge, we see, okay, we get little drops of current as the servo tries to move until I get past the breaking point. And now we can say, oh, okay, about 44,000 is the limit of that servo. The current increases. We get an increase in current as it goes down. And it stalls out the servo. Then if we stop the servo from being stalled out, it goes back to that nominal value of about 50,000. So thinking from 44,000 to 50,000 is not the way that I like to think. The standard thinking in Serial Wombat world is that as much as possible, we make everything range from 0 to 65,535. So our experiment with this servo and this gripper is that we can get a value from 44,000 to 50,000. So let's go back and transform that. And first of all, let's put an invert. Let's enable that output. And so now, okay, basically we're taking the input value and subtracting it from 65,535. So now if we drive an increase in current, we actually see the graph go up, which is good from an intuitive standpoint. And we want all of our signals to be as intuitive as possible. As engineers and Arduino hobbyists and electronics people, are we smart enough to handle all this? Yes, but if we convert the signals as early as possible so that they make sense to our heads, the likelihood that we'll make mistakes, introduce bugs, and the general ease that we'll have in using our system will be a lot more. So now that we've put the invert in, we can see that we get a range from about 15,000 up to, when we're stalled, let's say 22,000. So let's go back now and use that transform. And so now we dropped the input, it's down around 5,000. If we drive it all the way up, we get a value that goes up to 60,000. And we've left ourselves a little bit of headroom here for additional measurements if something changes and in fact the stall current goes a little higher or the nominal moves down a little bit. But we've moved this very close to our range for inputs of 0 to 65,535, and it moves in a direction that's highly logical. So this is very good from a input perspective. And now let's go ahead and additionally output an averaged value. Let's go ahead and take 64 samples on that thing going forward. And now this average samples, that reduces the amount of noise that we see. That'll help the control algorithm a little bit. And so actually let's make that 20 so that we get one sample about every so often that we're going to update the servo. So 20 samples at 1 sample per second, that's 20 milliseconds. So we can see we're jumping around right now. In our next video, we're going to look at using a PID control to limit how hard the servo grips and see if we can make it so that we can actually hold on to a device that way. The Serial Wombat firmware is available on GitHub and is constantly being updated. Subscribe below so that you can see the latest features and videos that come out as we fix bugs and add new features. The Serial Wombat open source project was created by Broadwell Consulting Incorporated. Broadwell Consulting Incorporated provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485, as well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting. Support requests for Serial Wombat should be sent to help@serialwombat.com and will be answered on an as-available basis. Also, feel free to leave your question in the comments below.